This is a quick tutorial on how to turn a PCB layout into a physical PCB board using a LPKF S63. So the equipment that we'll be using today is the LPKF S63 um, along with the CircuitPro software that comes along with it. So the first step is to open up the cover and find the green power button located on the bottom right. The next step is to hop on the computer and load CircuitPro. CircuitPro will automatically connect to the LPKF. It'll run through several steps and also calibrate the camera as well. It will notify you if there are any errors. For example, like if the cover is open or if it can't establish a connection, it'll tell you how to fix it or at least give you directions on how to debug. The next step opens up a new document window. You would head to templates, and this is where you select either single-sided or double-sided. We would select double-sided in our case. And it would show the different layers that the double-sided boards will have. The next step is to navigate to the top left and click on the process planning wizard. Here you'll select process PCB and either single-sided or double-sided. You'll also select the type of material. Typically we use FR4 and it'll give you a brief summary. The next step is to import your drill and Gerber files. And from there you'll have different layers that you have to assign these files to. So for example, this file is called B/CU. Is the bottom copper layer. There's a silkscreen bottom. There's a board outline and the top layer. And a drill file as well. So you just associate the files that the Gerber names correlate to. Next step is to create fiducials. Fiducials allow the camera to figure out the board orientation when you flip the copper board over. Select the fiducial icon. It's the one with the crosshairs. Typically you want a minimum of 3 fiducials. Here I place them on the bottom left corner, but you could place them on all 4 corners. That actually works a lot better. I placed the last fiducial a little too close to the board outline, so it's always nice to give it a little bit of room between the fiducials and your board. The next step is to navigate back up to the top and click on Generate Insulation and Contour Routing Toolpath. So this is the point where you select different rub out configurations. So you could either insulate more or less of the pads. You can also select different contour routing styles. So depending on how you want to break off your board at the end of the process, you could configure it with this setting. You can also fine-tune the settings by clicking on Show Details and adjust the tolerance and insulation width and gap width. Typically I leave these settings alone and they're pretty good at their defaults. Once that completes, it'll give you a list of different tools that is required for the whole process to complete. And from there, you would head back up to the top and select the tool icon. This will bring up the different tools that are currently loaded into the magazine. So on the left, it shows you each individual bits that's required for the uh, drilling process. If you need to change out bits, select the tools from the drop down menu, and it will correspond with the number that's on the tool magazine. You look for the required tool bit that the software says that you need to insert, and you go into the toolkit box and you find the correct drill bit. And if there's not an open space in the magazine holder, you just replace one that you're not currently using. And then you update the uh, tool in the dropdown with the bit that you just inserted. The next step is critical. In order to properly mill your board, this calibration step is for the width and the depth of the tooltip. It's essential for universal cutter, micro cutter, and end mill tools. In the holder column, check all of the boxes that are universal cutters, micro cutter, and end mill tool, and then select check milling width. At this point, you should navigate to an empty part of the board. This will score a 1-inch line for the machine to use as a reference. Once you've found an empty spot, click OK. From here, the camera will focus on the line that it just milled. Once you see that the line is in focus on the bottom left, click OK, and the software will automatically suggest adjustments for the milling width. At this point, you want to open up the cover and mount your PCB board on the top right of the tooling table. Also make sure it's securely taped down with masking tape. The next step requires you to head to the back of the machine and turn on the vacuum. And typically, you have to crawl under, the way it's situated, you have to crawl under the table itself. Once the board has been mounted and the vacuum has been turned on, click Start to start the board making process. So on this screen, you input the size of the board, but typically I use the drill as a reference. So with the cursor, I clicked on the top right of where I think the board is, and I adjust accordingly. And so I could click on the icon in the middle of the window that shifts the origin of the board. Once you have adjusted the origin of the board and also enter in the thickness of the copper and the board itself, click continue. The next step helps you orient the layout of your board. So you would use your milling head as a reference to where you want to place your layout. So move your milling head to an open position and then drag the layout to that crosshair. This window also allows me to set multiple boards. So if I wanted to make copies of a single board, I could lay them out in different configurations. As long as I know there's sufficient room to create a new board there, then I should be good to go. Click continue and save, and this will start the milling process. So once that first part completes, it's time to flip the board over the x-axis, and so you could see where your board orientation should be in the machine view. And so you got to make sure you tape it down and make sure everything is secured again. So once that's done, the camera will start focusing on the board, and this part is where the fiducials come into play. And so the camera will start trying to find the fiducials again, and once it finds it, it'll reorient the board and start the milling process again. Once that process is complete, you could go ahead and shut down the program, and this will automatically move the head to a safe position and open up the cover and pop out your board, and you should be able to start prototyping.